Hey everyone, so this is question number 5, section 14.4, and I thought to redo all the work on the table in Excel in order to reorganize it. So all the problems are the same, so you need this table on Excel. Okay, let's start. So here we collected a sample of 40 wines. All right, so this what this means is n is 40. We can go ahead and fill up, and then we are evaluating the wine quality according to how much alcohol in it, which is the variable x1, and how much chloride, which is the variable x2. Okay, so then that makes the k is equal to 2. So the only thing you gotta do is to fill up this table here. Everything else is generated, right? So in front of x1 you should have b1. So this is 043448. So we're gonna fill it up there, and then b2 should be in front of x2, and those are referred as the coefficient. So that's going to be negative 9 point. And then SB1 and SB2 are the corresponding standard of error, which is these ones, all right? So let's put them in. All right. So once we fill up this table, we can generate the t-statistics, all right? So t-statistic is going to be relatively to this formula. So basically the bj's divided by the standard of error, sbj's, right? Okay, so we're just going to put equal sign. We're going to click on b1 and divide it by the corresponding sb1. And we do the same for b2 and sb2. So equal sign b2 divided by sb2, and you can verify these two values that you just got with the t-statistic that you got here over here. All right, so we can copy them as well. So this one is going to be equals right here, and this one is going to be equals right here. Okay, now we can proceed to the confidence interval. So first of all, we need to fill up this table here. So this is really easy. Equal sign for b1, just refer it to b1. The c is going to be 95, the same as this one, so 0.95. Now the alpha over 2 has a formula, and that would be equal sign, open a parenthesis, and you're going to be 1 minus 0.95, that's the value, divided by 2. So this is alpha over 2. The n is the same. The n minus k minus 1, this is the degree of freedom. So you're going to be equal sign, the n, which is 40, minus the k, which is 2 here, minus 1. And that's going to be that value. SB1 is the same, so this one. And the decision, we can write it later on. Okay, so in order to calculate the confidence interval, we need to get the t alpha over 2. So the formula I wrote it over there, so that's going to be equal sign t dot inverse, and you can use either one of these. I'm going to stick with the inverse. So for this inverse, you need the probability of the left tail, and the left tail is the sum of these two values, the C plus the alpha over 2. And then you put a comma, and then you click on the degree of freedom, which is 37 here, and click and close the parentheses and enter. So this is a T alpha over 2. Okay, great. So now we're gonna proceed to the confidence interval, and I'm gonna use this formula here, which is Bj plus or minus T alpha over 2 times the standard error, which is SBJ. So you're gonna be equal sign here, and then I'm gonna click on the B1 minus sign, that the lower end, times T alpha over 2, which is this one, times the SB1, which is this one, and enter. So that's the lower end. The upper end, you're gonna be with a plus sign instead of a minus. So you're gonna be equal sign B1 first, and then plus, click on the T alpha over 2, multiplied by SB1, and enter. So this is your confidence interval. So let's input it. We should round to 4 decimals. So 49 before it was 7, so I'm going to take 49 and make 50. Okay, right now the hypothesis testing. So the null hypothesis or the hypothesis testing is going to be this one, out of the same statement. So this is going to be B. Now the T statistic is right here, and you want to round to 2 decimals, so is 82. The p-value right now, we did not calculate it yet. And you can see here I put 2 formulas. So whatever formula works for you better. I'm going to use the first one now. So equal sign T dot distribution, and I'm going to use 2 tails. And then I'm going to be using the X. The X is the T stat, comma, and the degree of freedom is going to be 37 here. So this is my p-value. And you might want to round to 4 decimals. Okay, so we're going to do the decision, and the decision here, we are comparing this value over here, the p-value, we are comparing it with the alpha value. So we compare these 2 values, and the formula goes, if the p-value is less than alpha, this is going to be reject H0, right? So this is, I think you learned this formula from the previous lessons. Okay, so the statement goes like this: equal sign, if statement, open a parenthesis. So the logical test, which is p-value, I click on the p-value, less than the alpha value, comma right now. So if this is the case, what is going to happen, between 2 quotations, you're going to put your statement. So if it is the case, you're going to be a reject, right? So we are rejecting H0. I can add as well, there is sufficient. There is sufficient evidence. I close the quotation, I put a comma, and open another quotation. So now I'm going to put the alternative scenario. If it's not the case, I'm going to do not reject, right? So the statement will go, do not reject A0, there is not sufficient evidence. Close the quotation, close the parentheses, and enter. And then you're going to get automatically the decision, right? So now going back, we know we did not reject. No, we reject, sorry. We go back and we reject, and there is sufficient evidence. check it. Good. Okay, we are pretty much done with the first part. So what we're gonna do right now, we're gonna start all over the question with B2 and SB2. All right, so we can select the statement. This is gonna be D, and we're gonna do the same work here. So this is the T statistics. I can select it, paste it, and round to 2 decimals. Okay, the p-value is already given to you on the table. You can even skip the work. All right, so the p-value for this is 0.167. I'll forget another 0. So it is the same value that is provided right here, right? And either we can run other test or either to compare it with the alpha. So what do you think about 0.01 and 0.05? So definitely the p-value is smaller, right? So if it is smaller, again here we reject A0, and if you reject, there is sufficient evidence. Okay, so what the meaning of rejection? Every time we reject in the multiple linear regression, that's a good sign. That means the alcohol has an effect or contribute on the quality of the wine. The same thing goes with the chloride. Has an effect since we reject the null hypothesis. So therefore, we want to keep the two variables in our model. And this will be include both models, both variables in the model. All right. And that's it.